For Lesson 8's homework, we're going to do some modeling with our systems of inequalities. Now, most of the time we solve these through graphing. There's not a great algebraic way to do it unless they start to give us some added information. But let's look at the first one. The theater charges $9 for each adult and $6 for each child ticket. The theater can sell at most, and there's the key word, at most 144 tickets. The total money collected from the ticket sales for that show was $1,200. Write a system of inequalities where A is the number of adult tickets and C is the number of child tickets. So the first inequality we're going to talk about is the fact that they can sell at most 144 tickets. So that would be A plus C has got to be, now if we say at most, that's the maximum capacity. They can sell less, but they can sell at most 144, so that's less than or equal to 144 tickets. Then the next one we'll deal with the money. So $9 per adult ticket plus $6 per children ticket. Now this one they told us was an equation basically, because they said the total ticket or the total money collected from those was $1,200. A lot of the times what they do is they'll say they need to do at least $1,200, and then you'll end up with that piece, a greater than or equal to 1,200. So now we'll look at the second part. If 25 child tickets were sold, what's the minimum number of adult tickets that must be sold to reach the desired income? So we're talking about the income question here. So we want to use the 9a, and we know that plus 6, and we're not going to plug in the C here. We know that that number is 25. I just realized I wrote two A's on the top, so it should be plus 6C equals 1,200. So now I'm just going to put this into my calculator and start to solve. 6 times 25 is 150. We'll subtract the 150 on both sides. 9a equals 1,050. We will divide both sides by 9. And let's see what we get. So we get A equals 116.66, repeating. Okay, so obviously you can't sell 0.66 of a ticket. So this is usually when they say in the very beginning, they say at least $1,200, because obviously there's no way to make exactly $1,200. But would 116 tickets be enough? No, they would have to sell 117 adult tickets to be able to reach that $1,200 that they're hoping to sell. Can 50 children see this movie and they still make enough money? Well, if we go to our original equation, or original inequality, I should say, if 50 children see the movie, that means that they are only allowed to sell 94 adult tickets. So if we plug that into our second one about the money, 9 times 94 plus 6 times 50, and we need that to equal the 1,200, or realistically be greater than or equal to that 1,200. And we plug that into our calculator, we get $1,146. Is that greater than 1,200? No. So the answer is no. They only make $1,146. So because they don't reach the desired income there, that's not possible that 50 children can see the movie, only allowing 94 adults to see it. In the second one, Jackie has 2 summer jobs. She works as a tutor, which pays her $12 per hour, and she works as a lifeguard, which pays her $9.50 per hour. She can work no more than 20 hours per week, but she wants to earn, and there's that word at least, $220 per week. Write a system of inequalities that can be used to represent this in terms of x and y, where x is the number of hours and y is the hours tutoring, and y is the number of hours as a lifeguard. So we're going to have one inequality that talks strictly about the money. So when she tutors, she gets $12 per hour, and she tutors for X hours. Plus, she gets $9.50 times Y for lifeguarding, and she wants to make at least $220. So that's going to be greater than or equal to, because at least means that number or more. For our second inequality, she can work no more than 20 hours. Well, that's the number of hours she works tutoring X, plus the number of hours she works as a lifeguard Y. And because she can work no more than 20 hours, that means she's 20 hours or less, which is less than or equal to 20. So those are our two inequalities that represent this. Without more information or without a graph, we can't solve this. So all we can do is just set it up like this.